Hello and welcome to Stars, Cells, and God. This is the show where we discuss new discoveries that take place at the frontiers of science, ones that have theological and philosophical implications, as well as new discoveries that point to the reality of God's existence. My name is Jeff Zweerink. I'll be your host today as we look into some topics related to artificial intelligence. But before we get into that discussion, I want to encourage you to subscribe to our channel, Reasons to Believe. Click on that bell icon so you can be informed of our new videos. You can learn more about us at reasons.org, and you can follow us on social media at RTB_official. So let's get started. Josh, I'm real excited to have you here today. If you could just take a couple of minutes and kind of give a little bit of bio for our audience here so they know who we're talking to.
Yeah, it's great to be here too. I'm a scientist at Washington University in St. Louis.
Okay.
Been doing artificial intelligence work for now it's been almost 25 years now.
So when you say doing artificial intelligence work, what does that mean? I mean, day to day, what are you actually doing most of the time?
Well, I mean, it started with my PhD in computer science back. I mean, so I have a medical degree, so I'm a physician, but then I got a PhD in computer science.
Okay.
That was focused on machine learning, which is one of the core areas of artificial intelligence, which is having an impact now.
Right.
And, I started in the early 2000s and was really trying to find these interesting problems at the intersection of biology, chemistry, and medicine that maybe AI could really help us make progress on. And so that's what I started my PhD on, and it ended up being what my lab started to take that on what I did. I ended up publishing, the majority of my work is in that space. I mean, it's a little ironic because most people now know about me from the work I've done in human origins, but the vast majority of my scientific work has been really in AI.
So I'm just curious, what got you, having a medical degree, being a doctor and being a computer scientist, those sort of seem a little disparate. What got you interested in both of those together?
Yeah, they do seem disparate. But about that time when I started graduate school, there was this new field rising of bioinformatics, computational biology. It was really with the sequencing of the human genome and that whole endeavor. Biologists really had a major transition when they started to realize, we really need to have people who understand how to work with large amounts of data and make inferences about them. And so they really start to invest more and more in actually creating training programs, collaborating and doing that. So now it's actually fairly common. I mean, most biology departments have professors that they hire that do research that's exclusively in a dry lab. That's what they call it. So it's just used on a computer,
right?
Without actually mixing chemicals or cells or anything. That's really common now, but that was very rare at the time. But
right.
I was kind of at the very beginning of that wave.
The
computer science program I was in was really designed to train people to do both computer science, but applied to biology.
Right. Okay.
And it was part of a combined degree for medicine. So it's because I'd been a pre-med and I was interested in this NISPR came out. So I was in school for a long time.
It sounds like it.
It's really about bringing together those different fields.
Very good. Well, I know you've got a discovery here, a research paper we want to talk about emergent properties. So why don't you go ahead and just give us a description of the paper. In particular, make sure you include what an emergent property is, or at least what that term means. So.
Yeah, so the paper we're talking about here, so that's the first one. It's called Emergent Abilities of Large Language Models. Are the emergent abilities of large language models a mirage? So that title's helpful. So let's go through the definitions you fit it. The first thing is, what do you mean by large language models, and why are we even talking about this? So most people know large language models by the name ChatGPT.
Right.
So that's where it really came onto the scene about a year and a half ago. And if you hadn't had a chance to play with it yet, you can get free access to it. There's also other companies that have similar ones you can actually get access and play around with. And what was really stunning about this for a lot of people is just how well these models were doing at tasks that we haven't usually thought computers were terribly good at.
Such as what? Because I know I've played around a little bit with ChatGPT, and it does really kind of have the flavor of you're talking with a person. I mean, I'll use the term mimics language very well. It does it very well. And, so what was the accomplishment, or how did that come about? Or
probably like the most precise and far-reaching explanation for what's going on at the same time is that I think it essentially solves a natural language problem. So normally computers could do very complicated mathematical analysis, but you have to do a lot of work to get it into a precise format that's easy for the computers to understand.
Okay.
Very regular, and maybe it might be somewhat human readable, but it would not have it would have a lot more precision than we're used to in our communication.
No, that makes sense. Yeah.
An idea of like just having a computer be able to do something useful with tweets or Facebook posts or science articles, that sort of stuff, had proven to be extremely difficult. You can get stuff that sort of works, but they would often have to be these like kind of small, narrowly focused sorts of questions, and they would be brittle. They would break, and they would not work with small changes or assumptions. And so, and still, you could do a lot of good, but people had just kind of really thought that. I mean, I thought, I was working in the field for a long time, that natural language just turns out to be really hard. Early on, we didn't know that. Computer science, people were kind of comparing the problem of natural language, which any human can do, right? Right. With the difficulty of chess, which only a few humans can play chess, right?
Right.
And they thought that that natural language would actually be a lot easier for that reason than
chess.
I mean, you just take a couple of years to get very good computer programs to play chess. Why is that? There's really not ambiguity in chess. Like there's rules, you know where all the pieces are, and you're just you don't know what the other person's going to do, but there's very easy ways to manage that. So getting a computer to do that, it turned out to be not that hard. But people found out really quickly is the whole natural language processing turned out to be very difficult. Now, part of that, I would say, is that there's just so much variety in the ways how we can see text and then kind of adjust that. And I mean, it's not just text; it's also like verbal too, right? Right. We can hear things, and so it's and there's it's not really possible to write it down in a single set of rules. And
no, that is true.
Always exceptions, and we actually kind of made ad hoc rules all the time as we're doing this.
Right.
So that's part of it. But then the other part of it, which I think is just as hard, is to really process natural language well. You have to have a really broad base of knowledge, of general knowledge.
Okay.
Of things. So if I kind of say, what's the color of the sky? What would you say?
Well, blue, most of the time.
Well, yeah, but I said, oh no, actually it's flat. And then you go like, oh, you mean it's nighttime?
Okay. Yeah.
Exactly.
Yeah.
So you know that, and you might even say that back and forth, but that's actually general knowledge, right?
Right. Yeah.
And to have an interaction now with a computer, you have to have really an immense amount of these sorts of like details about the world and how it's kind of embedded in it. And regardless, one way to do that is just kind of take how we think how it works with our rules from linguistics, trying to create big databases of knowledge. That approach, probably the farthest along that we've gotten in something like that would probably be something like Watson from IBM that people were kind of making a big deal about because it won Jeopardy.
Right. Okay. So Watson has a very different approach to this than ChatGPT does, or the language models we have now.
Yeah. So ChatGPT and large language models really solve the problem a different way. They're not taking human encoded rules and human encoded knowledge and then trying to kind of compute across that. What they do instead is they do something that's actually in some ways a lot simpler, in some ways a lot more complicated. They basically create a program that is inspired by the human brain. It's inspired by the brain that has the capacity to learn.
Right.
Presented stuff, and then they present out large amounts of text that it can learn from. It turns out that allows it to learn like quite a bit of the grammar rules you need.
Right. Okay.
And not only that, is that it can learn new rules based on what you tell it. You can tell it, like, I want you to talk in a particular way when you say this sort of thing, and it'll then kind of follow those rules as well too.
Right.
Kind of like how human might too, like this ability to actually kind of respond to kind of the narrow context. It has that ability, and it also has like really immense amounts of general knowledge, even stuff that doesn't even really fit into general knowledge, like just on a very like personalized sense. Like I asked it to write a bio of me. I just asked, write a bio for Josh Swamidass.
Okay.
And it gives a really good bio for me. That's accurate,
right?
Detailed. And so it knows who I am. And it's not because it went to, there are some versions that will look on the internet. This is just one that, this is just like the basic vanilla one that's not doing that. Just encoded. It knows who I am. It knows who reasons to believe it's.
So is that information that is part of its training set, presumably? Because I don't see how it could know you're a doctor unless something in the training said that, or is it able to infer that from something, or what?
Well, it's just trained on Wikipedia, right?
Okay,
I have a Wikipedia page, so
right?
Part of it. We also know that I've been mentioned in a lot of articles,
right? Okay,
work, right. And I've also published a lot of scientific articles that are in that domain. And so it's on the web, and those are the things that it's training off of. So that's
gotcha. Okay,
information. So, and I think what also helps is I have a very unique name. Right?
That probably does help. Yeah. So it's able to find the things that associated with you somewhat more easily because your unique name.
Essentially, at this point, if you find something on the internet that's about Joshua Swamidass, I mean, like 99.9 likelihood of talking about me.
That's fair point.
So, I mean, if you had a really common name, it doesn't work as well. And if you're really obscure, like you're kind of not been mentioned anywhere, then you won't be known. But that's still fairly niche knowledge. I mean,
yeah.
In a more systematic way, one of my friends at Stanford, Jonathan Cheng, who I did my PhD with, actually, he did the same thing, got a medical degree and a PhD in computer science. He's at Stanford now in the medicine department.
Right.
He actually took ChatGPT and asked it, second-year medical student questions, like from the boards that to do to get licensed in medical doctors. And he had them scored independently, the results from that ChatGPT gave versus what actual second-year students at Stanford,
right,
how they answered it.
Okay.
And it was a natural language text.
Yeah.
For what those actual questions were, and they were pretty complicated. You have to know a lot of very focused information, and you have to be able to reason about it correctly.
Right. Okay.
And then kind of explain your reasoning. You have to actually explain why you think it's there, and then the explanation of why actually. So it's not trivial to do this.
Yes.
And it turned out that by a substantial margin, the ChatGPT did better than second-year medical students on this.
Right.
And they've all gone to medical school. All this is kind of being trained on the literature. So that's like really surprising. So that's not like a specialist level. So like, if you go to a person who's in residency, they'll do better. Hopefully your physician that has a medical license, but not many people, a very tiny number or percentage of people in the country can do better at those questions than a second-year Stanford.
Right. Yeah. No, I get what you're saying. So
it's not really just general knowledge. It's actually fairly specialized. It's not as much as a human specialist.
Yeah.
But far better than most humans, even those that are pretty far into their training. So that's surprising, right?
Well, it's surprising, and it's not in this sense that most of the things, as I've looked at AI, as AI has played chess or it's learned to play poker or whatever, it's like there seems to be a fairly long learning curve of how to do it. But then once it does it, it tends to surpass human abilities to do that. That's kind of a general feature I've seen in there. And so the fact that it's doing it and now getting better is not so surprising. The fact that it can do it at all is surprising to me at some level.
Yeah, I mean, it is really surprising. I think there's a lot of things that I think are theologically potent or philosophically potent here that are interesting. So I think we can talk about why if you're curious, but I think most people are agreeing, though there is some dissent on this, but there's most people are agreeing that these large language models are not conscious. They don't have a mind, right?
Right, okay.
But a lot of Christian philosophers and philosophers just generally had thought that to kind of solve the language problem, you have to have a mind. To use human language, you have to have a mind. And they have arguments for that. But that means that now we kind of know that you can you can have human language without having a mind.
Well, so I'm going to ask, at some level I do, I would agree with that. And I'm curious, could you define, because you talk about solving the language problem or the natural language problem. What do you mean by that? Because when I think solving the problem, to me, it's almost kind of, I do find them almost synonymous that solving the problem means, they're thinking like us and reasoning like us. But it's the ChatGPTs are doing something a little bit different than what we're doing. And so what do you mean by solving the problem, I guess?
Well, solving the problem in the sense that it's another way to put it, it's essentially solved the hard problem of natural language processing.
Okay.
The way to do it, which is like, how do we get a computer to kind of deal with all of this nuance and all this background knowledge?
Okay.
To actually be able to kind of pick up a paper and be able to kind of summarize it and understand it, similar to how another human at that level of competence. And and to be able to do things like, if I was if we had like 1,000 tweets here and I wanted you to say, hey, can you tell me which of these can you tell me what the general themes are of those tweets, and can you also kind of categorize them into, and put them on a 5-point scale, how nice they are to how mean they are.
Okay.
Now, 1,000 tweets is a lot. It would take a lot of work, but really pretty much any person could do that, right?
Right.
And you do it. It'd just be a little bit tedious. You could do it. Now, to get a computer to do that, I'd have to actually code up what used to be, I had to code up a very specific program to try and do that. Very brittle, like I said.
Yeah.
But you can actually take ChatGPT and give it that question, and it'll give, in giving instructions that actually match really closely what I just said to you verbally for you to do it. And that would be enough for ChatGPT to actually solve that problem.
Okay, so it's
that's like natural language.
Okay, so it's able to use. Do you make a distinction between doing the process and doing it the way we do it?
Well, so it's not. So I think when it comes to how it does it, I do make a distinction between doing it versus doing it how we do it. Now, so that's actually what's interesting about this too, because like that older way of doing it, based on kind of like the rules we have. Or linguistics and like a database of knowledge is how we conceived of how language works for the human mind, but it's not actually how we do it either.
That's a fair point.
It's the engineer system, right?
Yeah. Well, it's part of it, but it's not the full thing by any stretch. So
yeah. So what's actually going on, which is surprising, is that there are important salient analogies between how ChatGPT is learning to do language and doing language to how we actually acquire language. It's not. So there are dissimilarities. Like it's running on silicon. We're running to different. We actually have bodies in this world. It doesn't. We have minds. It doesn't. So there are differences, and those are important differences. But there's also salient similarities. So,
give us a couple of the salient similarities, and then we'll kind of delve into the paper here a little bit more directly. So
yeah. So when you think about it, like, if you ever had a child you have kids, right? When they're little, they have the capacity to learn language, but they don't actually have it yet, right?
Okay.
And how do they learn it? It's by listening to other people talking.
Right.
And a big part of what they're even doing in their heads is trying to predict what's going to be coming next. It's a big part of how they're actually doing this.
Okay.
And they're observing that really carefully, and they start to kind of learn and say things. And then there is a feedback mechanism that isn't really happening in LLM, but the analogous part is by observing, people speaking English. It learns how to say that.
Right. Okay. I get what you're saying. Yeah.
Speak English. And if you asked, you have a lot of background facts in your head, right? Like, for example, the sky can be blue or it can be black. If it's black, it's probably nighttime.
Right.
So where is that actually stored in your brain?
I have no idea. It's somewhere up there.
No, exactly. It's somewhere up there. There's no way to really tell.
Okay.
And I mean, in that sense, your brain is really a black box. But I could still ask you your reasoning. If you said that, okay, well, oh yeah, black. Well, then why would you think that? And why would you say if it's black, it's probably nighttime? You'd be able to give me an answer. And so I could still get insight into your reasoning and how you're thinking about it.
Right.
Even if you can't tell me exactly where in your brain that comes from.
Okay.
So this is actually, once again, very highly analogous.
Interesting. Okay.
To what's going on with ChatGPT. So we can't actually point to any place that any of this data is stored. It's not like in a database somewhere. But I can tell you, it knows who I am. Right.
Well, because I asked that,
I might give an answer, and that's how I know if you.
It's fair point. Yeah. I want to come back to that in a few minutes, but I also, you have this paper you want to talk about, so let's do that. So these large language models, by kind of a new technique compared to past, have been able to solve the language problem, and that they can learn language and interact, and it, quite honestly, is pretty effective or pretty sophisticated language in a lot of ways. I mean, I find it remarkable that it can pass your second year boards as well as or better than most medical students. That's
pretty complex math too.
Yeah.
Amazing. Pretty well. Yeah. So, but then with this, though, people really said that they've been claimed that there was emergent properties.
Okay.
Out of this merely by their size.
So emergent meaning?
Yeah, so emergent can mean many different things, all right? So we're going to talk about what they've meant by it.
Okay.
And why this paper is really important. And I think it's basically right that a lot of the claims of emergence in LLMs, in this sense at least, aren't correct.
Are not correct.
Are not correct.
Okay.
But emergence means different things.
Okay.
It is surprising because all it's doing is trying to predict what the next token is, right?
Okay.
Yet it can learn how to do math that way. It can have these sorts of computations. Right. That's this type of thing where it is actually emergent in an important sense.
Okay.
But that's not the emergence we're talking about here. So we can talk about what that is.
Mm-hmm.
And you'll see that on the next slide here.
Okay.
So this is the first figure. Actually, this gets to one of the reasons why this is important. So one of the reasons why this actually happened. So this was a open letter signed by a lot of leading people in AI.
Yes.
It's saying that we should just pause making anything more complicated than ChatGPT for a good 6 months till we get a good handle on this, because we don't want to cause the end of humanity, because maybe there'll be some sort of magical ability things get once you get them large enough that we won't be able to understand.
Right.
That's basically the idea of emergence that people were worrying about.
Okay, so it's the idea that we're making progress, or we're doing stuff coming along, and then all of a sudden something dramatically new that could be detrimental to humanity might arise.
Yeah, as they get larger. And so because we're doing larger and larger things that are complicated, and right now there's models being trained that have more connections than the human brain.
Mm-hmm.
So in important senses, they're more complex than the human brain.
Okay.
And especially if you consider the fact that only a portion of our brain is devoted to language.
The fair point, yeah.
So almost certainly,
Well, there's more, when you say there's more connections, or I forget the term you used, but so that's, do these connections have the same level of complexity of the connections in our brain? Or I'm just kind of curious, because I know they keep talking about, you can have this many operations or whatever, but it seems to me there is some sort of complexity to the brains. It's not just a one-to-one correspondence or a digital correspondence and connections.
Yeah, so the human brain is really complicated, but part of that's just because it's biology, and biology is complicated.
Fair point, yeah.
And so one of the important things about what's happening in AI is it's kind of really been reducing down and simplifying what's necessary to produce complex computation.
Okay.
So it's certainly more simple in the versions that we program, but it's getting the part that's salient and really important for processing information.
Okay.
So and so you could also think about it a different way. In another sense, it's really complex what's going on in the computer, because if you start to kind of not abstract away the details of it's on silicon with transistors in a particular way, there's a lot of complex error correcting going on. It is actually fairly complicated. We're just ignoring all that when we talk about it from a programming point of view, right?
Okay.
And so there's something similar going on, that our brains are very complicated. Certainly, the connections between cells in our brain are more than merely a matrix multiplication. But and also there's a time series to these that isn't there with.
Right.
It's still getting the salient aspects in important ways.
Okay. Yeah, and that's not to minimize it. I was just, I find clarity helps talk about this. So there's a complexity in terms of the number of connections that hasn't been there before, that's rivaling or on the order of the human brain. There's details that nuance what that exactly means. So
I think it's probably very likely that ChatGPT has more basic facts that it knows than any individual person.
I would be surprised to find that not the case. So
yeah, exactly. Just on the basic level, it can make very surprisingly good translations between more languages,
right,
than any human has actually learned. So I mean that basic thing alone, it kind of tells us,
right,
just dealing with something very, very different. And that's kind of getting at the point that even though that they are simpler connections, they're capturing something very salient.
Oh, exactly, yeah.
So it's all able to do stuff that just on a brute force level, humans can't.
Mm-hmm.
something that, which is pretty remarkable. But the claim was, and they claim to have evidence. If you go to the next slide, you'll see it. And this is kind of illustrating, this is like the second figure from the paper. On the left-hand side there is an example of what emergence looks like from this point of view. And I'm going to explain to you what that graph is. On the right would be things that are not emergent.
Okay.
And so on the left-hand side, you can see on basically the y-axis is the performance or how well it's doing.
Right.
And then on the very bottom there is the model parameters, which is a measure of how many connections there are.
Okay, so as the model parameters go up, you're kind of making more, it's like adding more memory, adding more nodes, those sorts of things. Okay.
So if you look there in the first one and the bottom one, on the left-hand side, the C and the D there, you can see that the smaller models don't work at all, it seems, right?
Right.
And then all of a sudden, there's this big jump when you get from like the medium-sized one to the largest one, and between the two medium ones,
right,
where it goes from not really doing well at all to actually doing really, really well.
So kind of the idea is there's a property that's kind of latent or not even there, but once you get large enough, the property emerges.
Exactly.
That's what they're talking about here. Okay. Okay.
This is like a very narrow definition of emergence, but some people thought maybe this is how consciousness arises.
Okay.
And things like that. Like, there'll be a certain point you make them big enough, then something of like a switch flips somehow. Mm-hmm. You get just totally new behavior that you didn't get before.
Okay.
And that's kind of concerning because this is doing really amazing things that we didn't expect computers to do. So what's the next thing that's going to emerge? Right? That's a question that people are having and are wanting to get a solid answer to that.
Well, and might it be able to do something that we can't do? Yeah. So these are the sorts of ideas so this is why they're asking for that pause on developing bigger models or whatever, is because of this concern. Okay.
No one actually followed the pause. But that's why I didn't sign that letter, but that's another discussion.
Right.
But in contrast, if you say something that's not emergent, you can look at the E and the F on the right-hand side.
Right.
You can see how as the model size increases, it does smoothly better.
Yeah.
And so it's predictable. We could say, well, if we kind of, double the models, we can get a good prediction of what will be happening in the performance there.
Okay.
Just by kind of doing that. And you can see the same thing with the other one too, where there's like a lot of improvement initially, and then it kind of starts to level off, but it's actually doing that. So so that's the way how we can actually, that's kind of like the evidential claim that people were making. They were seeing examples like this that were emergent abilities, where it really seemed like to them that as you actually increase the size, you go from not really being able to do it to just doing really well.
Mm-hmm.
So I'll give you an example of one of the problems. There's like several problems with this case, but one that I'll give you is like basic arithmetic problems. So if you go to the next slide, I'll give you an example of something. So this is a addition problem that actually matches one that my second grade son is actually learned how to do this.
Nice. All right. Very good.
Right? And so now I know you can solve this.
Right.
Easily you do it by putting it into a calculator, right?
Actually, I was doing it in my head there, just making sure I don't want to look foolish by getting it wrong. So,
you could do it. And I'll make it easy for you. The number you get if you put it into a calculator would be the top one there.
Right.
The 9202. Okay.
Correct.
But let's look at these two other answers that are wrong. What's going on there? Well, or if this is the multiple choice, these would actually be pretty good. Oh, the second one would actually be a pretty good one to do, because that would be an example that would be a common mistake among kids.
Right, yeah, because they'll add the 7 and the 1, get the 8, and not recognize there might be more to the problem than that. So.
Well, yeah, they're forgetting to carry the 1.
Yeah, right.
So there's like an algorithm they're following. They forgot to carry the 1, and they got it wrong, right?
Right.
And it got an answer that's actually very, very far off. It's off by 1,000.
Right.
And it's not the right answer. So if what we're doing here is measuring whether or not you got the right answer, you make a tiny little mistake.
Gotcha.
Like
okay.
That. You've done a lot of stuff. You've shown that you know that 3 plus 9 is equal to 12, and then you can parry the 1, and then you kind of learned. You can do all that, but then you made a mistake,
right?
And you still get anything right.
Yeah.
And so that's the sort of a way you could look at this, where you would kind of say, okay, I can see why I mean, you can see why you might actually have more of this correct.
Yeah.
Then even like if you put the second one, that's actually a closer number. The third one there, the 9201. That's only one away.
Right.
From the other one, but that one doesn't make any sense because it's not a single mistake that's explaining how it ended up that way.
There's no, this is the one little thing you did to get there.
That 9 plus 3 is 11, but kids don't generally think that, right?
So wait a second, before we go on here, am I just wrong? Because it should be 9102. Should it not?
Maybe I put it in wrong.
Okay, all right.
Pretty quickly. But,
fair point. Okay, I know that people will look at that because I do. Anyway, so I get to your.
Got this wrong.
Fair point.
As a math person,
well, me too. I'm like, here, I'm agreeing with it too. So.
Well, you see, let's put it in the chat so you see if you can tell me what I could do wrong. So what's interesting about this, though, is that, we can have that reasoning about it, right? But the way how they were being assessed, what this paper noticed is that a lot of these problems are being called emergent or being assessed in that sort of way, where it's like all or none.
Oh, okay. So you could be 90% of the way right, but you're always wrong until you get it completely right. It's just saying you can't do it.
Yeah, or it could be more subtle. Like if it is like, well, how close are you to the right answer?
Mm-hmm.
If you're doing that based on, how far away you are, that's one metric, but I mean, that metric isn't really ideal because that's not how people make mistakes. That's not even how humans make mistakes.
Gotcha. Right. Okay.
Like if you look at how kids do it, they tend to get digits wrong.
Mm-hmm.
And so that could lead to very large gaps between the right answer and the wrong answer.
So if you had not a chat GPT, but a AI that got the 9201, you might evaluate and say, oh, that's closer, when in reality, that's a much larger mistake than the 9202.
Exactly.
Or the 8202.
Yeah, exactly.
Okay.
And you're not even really characterizing the difference between them.
Gotcha.
So
okay.
if you go to the next slide, this actually shows on problems kind of like that, what it actually looks like. Now, at the top, you'll see the accuracy metric. Okay. With the number of parameters there, and you can kind of see like a hockey stick shape to that with the harder problem. So, we're talking about the target length is how large. I mean, how many numbers or how many digits are in the correct answer.
Mm-hmm.
And if it's just one, so if it's just simple arithmetic, it's pretty quickly it doesn't seem to be emergent.
Okay.
Because you can see that it's just kind of like a smooth.
Okay, so that's the light yellow one up there on the top, or light orange.
But if you look at like if it's a 5-digit number, for example, that you're doing multiplication on, or addition or division, then you see kind of what they were saying before in terms of the emergence. You kind of see that with the lower models, it has no performance.
Yeah.
And then all of a sudden it bumps up.
Right.
And so people were looking at that and saying, hey, that's emergence.
Okay.
And they can't really do complex math unless you have a large number of these, a large number of parameters. And here's the evidence for this emergence that we're talking about. And so what they did is they took the exact same data, but they just measured the difference or like the error or the mistakes in a different way. Instead of, did you get it right or not, which is what accuracy is. They asked, what's the average edit distance? Like how many of the digits do I need to change to get it to be the right answer?
Okay.
That's a different thing, right?
Right.
So even if I have the thousands place wrong, it's
still just one token, yeah.
Versus if I have just like the very first digit wrong, that's still just one token. So those are equally bad, and we have a gradation because like maybe I have to change all of the digits because you got all of it. And when you do that, and then this is the exact same data set and the exact same answers, just scoring them differently, and all of a sudden you don't see that bend.
Right. Okay.
You can kind of see that it's just smoothly going up. And so, that's interesting on a lot of levels. First of all, it shows that it isn't like it couldn't do math before, then all of a sudden it can. It's that it's getting progressively better, but it's in a very predictable sort of progression.
So this is some of these emergent properties are really just, or what look to be emergent properties are an outworking of us. The metric we're using to measure it is incorrect.
It's like an artifact.
Okay.
How we've looked at it. So there isn't something like mysterious and like entirely unpredictable going on here.
Right.
It's just that they're getting better and better. And I think what's remarkable about this too, it gives a pretty strong indication that I don't think it's been fully explored yet, that it's making mistakes in a way that's similar to how we make mistakes about it, which is remarkable too.
Right.
We can I basically put this into a calculator and maybe got the wrong answer, right?
Okay.
If we got it, we know exactly how that would have happened. I just probably put the wrong number into the calculator when I hit enter, or copied over wrong. Right?
Yes.
Right. But if I put it incorrectly and I don't copy it incorrectly, calculators are not going to make mistakes on problems like that, right?
That is correct.
And so it'd be very weird if a calculator was starting to make mistakes.
Is it?
What's interesting is that if we're dealing with humans, actually one of the early ways that people were able to figure out in the Turing test that it was a human you're talking, not to a computer, is if you ask it like a math problem like that, because
it would make little mistakes. Yeah.
And then humans would make little mistakes in it.
Yeah.
Oh, that's the human. And so it's like a very human sort of thing to kind of
right.
know how it works, but kind of just forget to apply the rule at one time and do that and kind of get a digit wrong.
Yeah.
So it's making...
I'm glad I'm not the only one. That was perpetually my problem. I was like, I'm pretty good at math, but I can't tell you how many algebra errors I make. It just happens. I mean...
It does, because, part of I think what's good for kids to learn arithmetic, my son was asking me, why do you have to learn through the calculator? So I'm checking all this homework in the calculator. I was like, wait a minute.
Yeah.
Just use that. I said, because you have to learn how to do it.
Right.
And part of what he's learning too is to start to be like careful and precise.
Yes.
To apply it. So that's a skill that he's learning. That's important. And yes, it's normal. That's just what happens, right?
Yeah.
Eventually then we'll move to using calculators, but even then we'll make mistakes if we're not careful enough, like I probably did here.
Yeah.
That's the exact sort of mistakes that ChatGPT makes, not because we programmed it to, but because it, in an important salient way, I would say, it's doing it in a way that's very similar to us.
So I am curious, and this may be a discussion beyond this particular one. So my understanding is that ChatGPT, there's a large body of data, stuff off the internet, various things. Yeah, it was trained off Wikipedia, sorts of things. That, so when I make that sort of mistake, I will add 8 plus 2 and get 11 instead of 10 for whatever reason. I couldn't even replicate what's going on in my mind, but I know that 8 plus 2 is 10. When ChatGPT does something like that, is it just mirroring the mistakes that we've made, or is it the process is going through something akin to what humans do? Or can we even answer that?
Like I said, I think there's going to be analogies and disanalogies.
Okay.
There's going to be a lot of scientific work done and kind of teasing that out. But I would say it's far more saliently similar to us than as a calculator.
That's fair.
The way how it's doing it. And that's interesting too, that's actually how we solved this, is by kind of mirroring in that sort of way. So that's so it is similar, but it and I'd say in a lot of ways, like, if a calculator did get it wrong, if you ask the calculator how did it get it wrong, why did it get it wrong, it can't tell you. If it gets it right and you ask it to explain the steps by which it used to get that answer, it can't do it. One of the things that we've actually found, which is also mirrors very much human behavior, is if I actually asked you to a math question like that until you give me the answer, there'll be a certain accuracy you'll get out of that, right? But if on the other hand, I tell you, okay, I want you to actually step-by-step work this out and show me all your steps to compute the answer, it'll actually be a better accuracy.
Yeah, because you're being more deliberate. You're less likely to make the quick error or whatever it is that you do, yeah.
Yeah, and I can also then see, too, that you're using the same process. And all of that sort of stuff. That's what we're asked to show our work in math class, right?
Right.
Not just do it in our heads. Well, when you kind of ask these questions to ChatGPT, you can do it in either way. You can just say, here's the question, give me your answer, and it'll do it. And it actually ends up mimicking this human visual. It'll be a lower accuracy than when you say, okay, can you do it? But actually, show me step-by-step how you're doing it. Do a lot better.
That is interesting. And what I find interesting about that is that the reason I make the error is I start thinking about the next thing. I just have a brain glitch, who knows what. Kind of the whole point of computers is that sort of stuff isn't supposed to happen. So that's why I'm kind of curious what the mechanism behind making those errors. Is it just part of there's enough of those examples where there's in all the training 8 + 2 = 11 sometimes, and so occasionally it will do that, or if it's something else.
That might be part of it, but I mean, I don't know if that's really the primary thing. I think, there's other weird things people found that so there's actually some pretty cool prompt optimizers now where you use like an LLM to figure out a better way to prompt it. It doesn't automatically to figure out the right way to do it. So someone did this with these math problems and found out that by telling that this is not something they would have predicted. They didn't do this intentionally. It's just like the optimizer figured out.
Okay.
That telling the LLM to act as if they're in Star Trek.
Okay.
In that voice, then it would actually do a lot better in the math problems. And so that's like totally surprising, right?
Well, it is and it isn't in my way of thinking about it, because you look at Star Trek, there's not going to be those errors in there because they're going to be very intentional about not doing it. Right.
So that's so we don't know if it's just because there was data there, but it actually might be something at a much higher level where they're kind of saying, oh, this is really highbrow sci-fi. We're wanting to make mistakes, and it's really precise. So we're going to try to be a lot more precise in how we do this. So,
well, that could be,
on that level, right? Because there's not a lot of math problems that you're seeing in the training set if you look at, fan fiction for Star Trek. And
fair point. I think this is one of the questions I have, or as I've thought about these language models and everything, is that, I agree with your assessment. It's remarkable what they've done and how the things that can be accomplished through these large language models are incredible. It does seem like they're doing something different, and I've in my mind tried to make a distinction between, it's like I don't have a conversation with ChatGPT, because in conversing, I'm very intentionally got ideas that I'm trying to communicate with you, and I use words to do that. I don't know that ChatGPT is doing that. It's doing the same thing I'm doing, and we're conversing on one level, and that the conversation looks the same. But it does seem like there's something very different that we're doing. So there's analogies and disanalogies in there. So.
Well, I think it's complicated because it's a moving target. It's kind of depend on kind of the type of questions we ask. So if you ask it to do particular things, it'll be really compliant and try and do that because that's how they kind of designed it. But you can ask it to do something very open-ended. So you could actually say, respond with something interesting. It's very open-ended, or try to teach me something interesting.
Right.
And so then it'll actually respond, and then it'll have an agenda of its own that it kind of made. With that you didn't predict, that you didn't actually give it. You just kind of gave it the freedom to kind of come up with something itself.
But my question in there is, so you asked me to do something interesting. I'm immediately putting ideas together in my head to try and answer interesting, as opposed to I'm predicting words together to come up with something interesting. And then that's what I wonder. And maybe we can't answer it now, but
yeah. So this gets to one of the big differences between like a vanilla ChatGPT and our brains. Like one of the big differences. I think one of the strong reasons I think we can say, it's one of many reasons we can say that it doesn't actually have a mind, is that ChatGPT doesn't really have an inner dialogue.
Meaning, just flesh that out. I know what the words mean. Just
they do something interesting. I think, what do I do?
Right.
And this, you kind of doing this pre-planning thing.
Right. Yeah.
And often it'll be in like kind of your language of origin. So if if we're doing an interview in Spanish, I'd probably be still thinking that way in English, right?
Right. Yes.
So we're having this inner dialogue with ourselves, right? And then we kind of go to actually do it based on the plan, right? So that's not typically what's going on with ChatGPT, though you can kind of emulate that. Which is like, you could say, develop a plan to tell me something really interesting. And then imagine that just being like in the LLM's head, right?
Right.
And then it's okay, now actually do it. So then it starts to be actually not as different, just because we asked it to kind of follow a process that's more similar to us,
Right.
Does that make sense?
It does.
It's true. So there's some really, really cool things that people building on top of LLMs that actually do start to have these sorts of behaviors. Well, there'll be an inner dialogue that's happening that's not actually presented to the users.
Right. And I think where I find that distinction in there is that I am my I don't know, conviction's not the right word. My intuition is we're going to make AIs at some point that are so effective at mirroring and mimicking human behavior that we can't tell the difference between them. But it's, and this is where, kind of your analogy and disanalogy. It's like they're more and more mirroring the process by which we do, but it seems like there's something different there about the way I do it. Because even when you start thinking about, I said, okay, these AIs are giving very good answers, very articulate answers, and reasoning well. My immediate thought is, that's the way I do it, so I'm going to assume that that's the way it does it. And then I find out, it's doing it a little differently. So I say, okay, well, here's how I do it. I can increasingly tell it to do. That's part of what I find so fascinating about these is you say, okay, have an inner dialogue about doing it. And it can do that, which it wasn't. There's nothing in its training that told it to do that. But yet in the training set, it can figure out what that means and do it. That's just incredible in my mind.
Yeah, it is really remarkable, honestly. It's surprising. I think it's fair to say that it's a general intelligence. It's not a mind. Doesn't mean it has a general intelligence. It's not a specific sort of AI. It's not specific for a single task. It's general, and it's not just merely parroting stuff. So, like for example, on the internet, there's tons of really bad behavior and racist things going on, and cussing. But it doesn't actually use those words usually, even though that stuff is out there really commonly. You tell it, I want you to act as a very helpful assistant and, not be rude and be helpful. It won't cuss at you. It won't get upset. It'll actually follow those rules. And the part it's able to do that, it's in the same way that we've all been exposed to bad words and we know how to delete them, even if we don't ever say them, right? And it has the ability to do that too, to kind of learn about stuff, but not actually emulate it if it wants to. And using a lot of categories that are similar to how we have the categories and how to distinguish between those two. That's just surprising. So it's not just merely copying, right?
I wonder if that, and I don't know, but given the breadth, this enormous database out there, one of the questions I would have is there just a large enough sample of what's out there? So, the idea of it saying, okay, it's not cussing. It's like when you find the connections out there, how you prompt and what you say, there's ample data in there to come up with that connection in my mind. I don't even know how you would do that, but could it come up with a truly novel thought? Something that is not just an extrapolation of the database, or either an interpolation or a somewhat of an extrapolation of what's there. And I don't know.
So you could actually ask it that question and see what it says, right?
Yeah, no.
I'd be curious.
Yeah.
I think that it all depends what you mean by that. Like, some people have argued that even among humans, none of our thoughts are actually truly novel. They're, with all of our ideas are really derivative. You are starting with a base of knowledge and maybe combining it with another base of knowledge for like a connection that other people had overlooked.
Yeah.
But how many of us have come up with a truly novel? Like my book has been called pretty novel when I talk about, human ancestry and,
right.
But I didn't actually come up with anything new. I put it another way. It was a little bit surprising. Some people called it, people have called it very novel in a very narrow sense it is.
Yes.
But very quickly, you find out that it has a lot of precedence to it. It actually maybe as novel as people thought. It was just overlooked.
Yeah.
I think so it would be strange to kind of impose a different type of novelty determination on ideas like on ChatGPT.
No, that's a fair point. And I know that one struggle I have is that there's a limit to how many facts, how much things I can store in my brain. It seems like at some level, these large language models don't have that limitation. And so it wouldn't surprise me that some of the things I do, it does in a different way. And so, I've enjoyed in talking just because it's kind of opened up new ideas and allowed me to, know what the boundaries are and what is and isn't true there. And so it's been very helpful in that. So Anything left to say about the paper? Or I find this idea of, I know there's a lot of talk about emergence, and at least in this particular area, just recognizing that that's often a result of what we're measuring, not that there's truly new things coming about in there. I think that's an important...
Yeah, but we don't want to store it away under the term emergence, really, because there's many ways to use the word emergent.
Okay. So how would you summarize it then?
I would say is that this idea that, as we kind of make these models bigger, and it kind of goes that there's going to be these big, surprising things that could never have been predicted. Merely just by making bigger models, it is just not correct. That's not how these things work.
Right.
It's actually a lot more predictable and understandable what's happening. Because they're, and then that was just an artifact of actually the metrics. Mm-hmm. But as sort of looking at it, I mean, it should get us thinking more deeply. These things are actually working a lot more saliently similar to the human brain than computers really ever have. And they're able to do things in surprising ways. So, I mean, it's kind of cool.
I would agree very much. I just appreciate the conversation. Thanks for joining us today. And I want to thank you for joining us as well on Stars, Cells, and God. I want to encourage you to join the discussion in the comments below. Let us know what you think and what your questions and issues are. Remember to like this video so that you can subscribe for more content. We realize that new episodes of Stars, Cells, and God release each Wednesday. They're available here on YouTube and in your latest podcast app. Be sure to share this video with a friend. And remember, the more we know about science, the more reasons we have to believe.